So I'm John Murphy, I'm the CEO of Stream, and with me today I've got Lee Marsh, he's our CTO. And the idea here today is to share a little bit about what Stream is up to around machine learning, and kick it around a little bit, just to get a little bit more feedback from you folks. So there will be a little bit of a presentation here where I just kind of show you what we're up to, and then we'll have a Q&A where we can just try to get back some answers or some questions you guys might have. So there's a couple different tacks that I'm taking. So as the CTO, I am the non-technical CTO, CEO. He's the CTO. I can't even get my EIOs right here. So if there's technical questions, we're going to bring Lee in. I'll pass him the mic and we can kind of go a little bit deeper. So Stream is a company, and we just launched last night at the launch party, stream.ml. And so this is our product website that is all about machine learning, and in particular a focus on machine vision. So we're going to talk a little bit about that.
Could you lower the volume a little bit?
Lower the volume? Yeah. Here, I can take this away down here. How's that? Is that any better?
I think you control the line on that launcher.
I'm analog here.
Do you want to go to full screen for your
How's that?
presentation?
Well, you know what? I could go full screen, but then I just made this. I've kind of like made this presentation up a little bit last minute, so sometimes I might have to jump around. So I keep this up there just so I can jump around and not look like I don't know what I'm doing. But it's too late. I've already admitted it. So. Okay. So the game here is to be able to take images, different cameras. The images, we're going to actually then do the analytics with our platform, StreamML, and the result is we provide a prediction. So that's just high level. Here's the game that we're at. So interestingly, we're working with folks like Canon. So Canon sees that their cameras can go from just taking pretty pictures of our kids and our families to actually being something that could be an analytics device, if it can actually do predictions. So it's kind of interesting from the hardware, and we'll talk a little bit more about some of the hardware ideas that we're working on are with some of our partners. What you see here is a multispectral camera, so we do things in both with RGB images and with multispectral. This is a camera that we developed, but we're not really trying to be in the hardware business. This was just a prototype to kind of making sure that we really understood the signals and the type of data that's coming in from these devices, so that as we do the analytics with machine learning, that we're doing it all right from right all the way through. So just a little bit of positioning. So Stream.ml, if we're going to do analytics and return these prediction sets, we want to be working with companies and people who are actually on the application layer, right? So there's people that have got drones or all kinds of data capture devices, and then they have an application where they might be selling reports, or they might be selling maps, and now, but they're, as software developers, app developers, they might not have a data scientist group on staff. So then how do they take advantage of machine learning? And the idea here is they're going to actually, from their application, they're going to send images, we'll do the analytics, send back the results, and that's all going to happen through an API. And I can show you this a little bit deeper, but just so we're all on the same page as to what's going on. So generally, we're going to talk a little bit about some of the hardware that what's actually collecting the signal. Because I mentioned cameras quite a bit, but with a crowd like this, it's not just cameras; it's spectrometers. It could be gamma rays. Who knows what you guys are working on? So it's about signal processing in some cases and image processing in other cases. We're going to talk about deploying a little bit, models, and then we're going to talk about, hey, if you actually did get into this for real, how might you be motivated to want to do it, and how can you make some money? Right? So this is pretty high level. I know that this I won't take much time, but just so we're clear where we're fitting. We're down here. I mean, this is where we focus on machine learning, specifically deep learning, a lot of neural nets, and then specifically computer vision. So we're not trying to be everything to everybody here. That's our area of focus, and we also focus a little bit on spectral data in addition to spatial. So when we talk about spatial analytics, we're talking about things, TensorFlow, that you might, and basically we're looking at size, shape, texture, right? Using, in a lot of cases, RGB images. But we also do things on the spectral side, so light and the different wavelengths of light. And so just my quick example is, sure, facial analytics could tell us that that's a person and that's a person. But and that's spatial, so if we add the spectral side, now we say that's skin and that his face is paper, and that gives us better information now to make a decision. If you had an autonomous vehicle that had to run over one of those people, pick the guy with the paper face, right? So, and that has a lot of applications when we can start to overlap these convolutional neural nets, and they can feed on each other. Okay. We don't have it all done right now, so just some in the world of classification, we're kind of up at the top right there with the RGB stuff and on the automation, and we do some of this semantic segmentation with multispectral. And so I'm just saying that we don't do it all, but this is on our roadmap as we continue to develop the product. There's just a little bit of background. Data capture. We're going to talk about software, and then I'll get into. We'll talk about some data capture, and then we'll get into the analytics piece in just a sec. Okay. So we talk about capturing information with cameras, but these can be RGB cameras, like we kind of talked about, but they can also be spectrometers. We're working with companies that are putting spectrometers into probes. So you walk around and put the probe into the soil, and it actually then does spectroscopy with the soil. And the idea there is to get a signal and then run it through the analytics and find out how much nutrients is in the dirt, how much nitrogen, how much sulfur, that kind of thing. So that's kind of, there's a lot of different types of data capture, and so if you're working with ultrasound or gamma, I don't know what. Let's just don't make the assumption that we can't help there, even though it might not be supported initially on like a drag and drop rule. That'll make more sense in a minute. Okay, I popped this one up here just to kind of say, because we were working with Duncan Elliott, and I know that maybe some of you guys have been working or know him, and his team put together a little bit of a camera, a multispectral camera on a drone. We also are working with a company that built, and we're with them, building a camera. It's a multispectral camera to take images instead of typically from an airplane. So instead of typically taking an image from a plane that might be cover 400 meters on the ground, this particular camera can cover 10 kilometers. And it's high resolution, and it's multispectral. So that brings in a lot of interesting data that we can start to look at how we're going to do analytics on. So again, just a data capture device. Here's a different kind. This is a spectrometer. We built this box so we've got like the universities. There's the University of Saskatchewan. Olds has got a box like this. They're doing protein in barley, as an example. There's the example of a probe going into the soil. We capture things with gantries in greenhouses. So, and some of this hardware, when you want to be able to take a picture, you want your hardware taking the picture. Maybe it's taking it every 10 seconds, and we want that data automatically sent up into your account of of StreamML, and we can do that through an open API, it's an open hardware API called ONSI. This is up on GitHub. So if you have any hardware that you want to have automatically be sending information, there's a nice way to be able to do that. Okay, so now kind of high level, machine learning, and how do we build models. So at the high level here, and maybe I can just keep an eye on the timing. And so right now, I just jumped over here to our site. So basically, it kind of looks like this. You go to stream.ml, and you can all do this, and it's all free, okay, for you guys. So if you go here, you create an account, and now I'm just going to show you how someone might build a model using the tool. So I'm going to go into Model Builder, and I'm just going to go down here to, oh, just wait a minute. Am I in dev here? No, that's all good. I'm going to cheat a little bit because I've kind of got this one a little bit already done. Okay, so one of the first things that we want to be able to do when we're going to build a model, and this is supervised learning, so we're going to bring in some data, and here I've got some training images, and in my example here, we had a guy that he had a drone. And he wanted to actually find out if he wanted to take pictures of a crop, and he wanted to know whether caribou been walking through and trampling the crop, because the insurance company will pay them money, right, if they damage the crop. So they had to have this algorithm and model to be able to find out, have caribou been trampling my crop? So here's the deal. He had to upload some images, some training images. So he went with a drone, and he took about 400 pictures of crop that had trampling in it, okay? And he uploaded them, okay? It's free, you log in, you upload the pictures. And then he took 400 pictures of a crop, and there was no trampling in it. So, and basically he just uploaded the pictures. And then he filled in the form. So this particular form, he put the name, this is trampled crops, a little description, he put a little picture, and then he said what kind of hardware are you using? In this case it was an RGB camera, so we filled in RGB, and what type of classification, and we can support binary, we can support multi-class, or we can support regression. So this particular example is binary, and the components then are trampled or non-trampled. Components of what he cares to build a model around. And the next step is he pushes this train button right here. And that's kind of it. And once you push the train button, what happens in the background that you don't see is that data is then taken and it's pumped into our system where we've got a bunch of neural nets running, and we're going to build models, and then we're going to evaluate which model might be the best, and then we'll pick that, and we'll build a report around that model, and we'll pop it up. And remember, this is all free, because I'm hoping you guys are going to log in here and give this a go afterwards, just so you know. So, so there's nothing really to show there, because that's just what you do. You push the train button. And in part of this, what we're trying to do is we talk about democratizing machine learning, because in this there might be a lot of data scientists in this room, but when we get out into industry, what we find is there's a lot of software developers, but they don't necessarily have the background in machine learning to build their own models. So how can they just make a call and do this? But so they can push the train button, they can upload data and push the train button, and then the next thing is they want to be able to see a report. So this training process could take 10 minutes, it could take a day, depending on how many images you uploaded and what's going on. But either way, it just walks through and it'll tell you when it's trained, and now you view the report. And we've kind of color coded this, so I put this particular report up just because it's got, for folks like me, it's color coded. So I can see, hey, green is good, yellow, hey, that's probably okay. Well, red, we might have a wee bit of a problem. And then, obviously, we put all the numerical values for folks that actually know what's going on as far as being able to read a machine learning report, and we can go deep here, but I'm just keeping it high level right now. Okay, so now you see the report. Let's just say it's got an accuracy of 82%. You're happy with that. Now, what happens is you got a model. It's built. It'll actually look at these trampled images, and it'll do a prediction and send back the result. So now you've got an application here, but how do you call? How do you engage that? How do you call that? So you use a simple REST API, and then for that you jump over to Model Manager, and your algorithm will pop up here, and it'll automatically build a token, and then for the code that you're going to basically put into your application, you're going to access. Here it is. It's 2 lines of code. You use the token. You put in your data, your picture, and you use the URL, and it'll just automatically go to our site. The analytics will be done, and we'll return a prediction back to you, right? So, and so here's an example of just remember, we're not the folks that create the application, right? We want to work with companies that do that. We're the prediction providers. Okay. Here's just a quick example of, I must have here. Here's our crop trampling. So here would just be a sample image to test, and you open it up and it runs the model called trampled crops, because that's what we called it. Here's your components, and so the prediction is we're 99.8% confident that there's trampling in that picture. And of course, we can see there's trampling, because I can't put up a picture with no trampling and then say there's trampling. Everybody starts asking me questions. So it's kind of obvious, but that's just how these demos go. Okay. Does that make sense? Questions? Any like, if anybody's just kind of so confused at this point, put up your hand and I'll take another swing at it.
Question.
Yeah.
Is it just saying that it's this or that, like classification? It doesn't say any information about where is it, and I don't know if it's important or.
Yeah. So in this example, it was a binary. We use binary, so it's either one or the other, and it's going to make a prediction on one of those components, right? I keep saying I'll just check with the boss over here once in a while, just to make sure that I'm answering properly. Okay. So there's other pieces to this website here. Again, you can log in and just try it out yourself. It's all free. So now I just want to jump back here a little bit. So what I just kind of showed you was you can upload images and you can push the train button. Okay, so we just kind of went through it more live instead of with the PowerPoint. And there's the report. So there's also some other models that are already pre-built, and I guess I could jump back and show you that. But so this is things like VGG 16, yeah.
But John, it sounds like as long as you can put it into a set of data cubes, and you've got some supervision of how to do the initial classification, it doesn't matter whether it's images or, like you say, it could be a multi-sound array, it could be sonar, it doesn't really matter, right?
That's right. But I'll just show you one little kind of automation step that we made it a little bit easier, and to do that. So when you go, and if you're going to actually upload your data, you can create a new folder here, and you just click the new folder button, and then we kind of ask you, are you uploading spectral imaging, multispectral data from a multispectral camera or a hyperspectral camera, something like that, or are you uploading spectrometer type data, or are you uploading an RGB data? And then depending on what you click on, we're going to ask you a couple more questions about that particular hardware. What kind of spectrometer do you have? So if you had something that was just not in here, we're kind of architected that if you worked with us just a little bit, you know, we could probably work with that data set, no problem. But I just don't have it so like drag and drop easy for all the data types and the formats right now. Does that make sense? Yeah. So it's kind of a data format thing. Yeah.
What kind of validation split do you use?
What kind of validation split?
Sure, usually around an 80-20 as like a default validation split. That answers your question.
Yeah. The old validation split question. I knew it was coming. Okay. Now I'm going to jump back to. Okay, so you know what? This is just so much easier to show. I'm going to show this one right here. So okay, wait. Sorry. I'm just going to jump past this for a minute. We've already talked a little bit about. Yeah. Question.
I probably missed that, but at what point did you define the future map that you're going to be predicting? Like you load those pictures, but you have to tell what is it that you're looking for. At that point, you do that with these images.
Yeah, you did. We did that through the component step. So when we were doing the. Oh, whoops. Hang on, this is undo. Too late.
There you go. I think you had it right there, though. Just one up.
I know my little mouse.
You can see it's in the bottom left there.
Yeah. Okay. So back down here, we defined this as trampled and non-trampled, and that it was a binary. It was just a binary model. So those were the two components. Am I answer? Did I?
You're not doing segmentation.
Yeah, we're not doing
That's his
segmentation.
question.
That's a good point.
I think that's
Oh,
what
yeah.
his question was.
Okay. Does that answer it?
No, it's not.
Okay.
Not for me. I mean,
Yeah.
It's so general. So I guess you're looking for that line,
Oh, okay.
that track of whatever you are interested in. But by saying that is enough.
Yeah.
Yes. That is, yes.
Yeah. That's enough. We love neural nets. Okay.
So how many pictures do you need to train that?
Okay, so the question was how many pictures do we need to train it? So we don't let you actually push the train button unless you have at least 100 pictures, just because we got nothing to work with. We'd like 800, we'd like 1,000. But once you have in 100, you can push the button and away you go. And then you can see the report. It might not be that great depending on what's going on. But I mean, there's some transfer learning and stuff going on all in the background here, so it's not like we're starting from scratch on all these things, right? And there may be some applications where we need thousands of images to really get her cranked.
Yeah, and that's entirely correct. So because we're using transfer learning for some of this, is it will learn some things much faster and much easier than others. So like he says, you can try with 100, you might get something, or you might actually need to upload 1,000 or 10,000 before you actually get meaningful results.
Okay, we talked a little bit about how you deploy this, because you would just make a call with a REST API so what are you calling? You're calling the cloud service there, but this is also packaged up with Docker containers, if I'm using the right. But so we can also host this on premise or on edge. Okay.
What is on-premise? On-premise?
So instead of going to the cloud, we've got customers that want to actually put a server on location, and then the one server will take images real time from maybe 100 different cameras. So you can imagine a big greenhouse with 500 cameras, and they're all taking pictures, and they're all being processed through basically real time, and that's all happening on a computer that's in their facility. So we call that on premise. And then in some applications, you're actually walking around like this guy here. If he wants to see results real time, he's not going to the cloud. There's actually a processor in his knapsack there, and so we just call that running on the edge. So this is just a local processor. So the point is we can package up the models to be executed in all those environments.
So in those use cases, so obviously the guy in the field that has his in his backpack, he doesn't have access to the internet. right in the
Right.
middle of the field wherever he is. And then for on-site, is it due to speed or is it due to security of their data that they would want on-site? System?
Yeah, and the answer is both, right? So when we're dealing with military folks, they're just not going to the cloud. It doesn't really matter what's going on. It's not happening. When you're dealing with something on a conveyor belt and you just need to be making millisecond, your model's got to be running in milliseconds. Then you're going to be using an on-premise. So both of those things are appropriate. What's the okay? So I'll come back to that because there's kind of two ways that we make money and some of the ways you make money. So this was the deploy step, right? So it's one thing to build a model, it's another thing to deploy it, and we just want to take care of both of those pieces. Real simple. So the other thing is our marketplace. So now, if you've gone in here, you've uploaded your images, and you push the train button, and you're happy with the thing, you built a model. We know that it can be deployed through a simple call, but now you have the ability to actually monetize that. So basically, you put the model into our marketplace for sale. It's your model, it was your data, you push the train button, so you set the price. How much per prediction is anybody in the world? If anybody in the world buys your model and uses it in industry, how much per prediction do they have to pay? Maybe 5 cents, maybe 10 cents, whatever. You set the price. And then what we do is 85% of the worldwide revenue that comes off of the use of your model, we pay back to you. Okay? And then we keep 15%. So that's one way we make money. But it was your data. You push the train button, so you get 85%. And when you sign up, this is all kind of backed up with a payment gateway. What's it?
It's like a merchant account.
Yeah, Stripe or
Yep.
And so you can have a merchant account, and then each month the money will just be transferred back into your account. Okay. So that's a little bit about the marketplace. But I think that one of the cool things about this is, you can imagine so there's John Deere with a spectrometer box there, and it runs a model right now, and it can detect nitrogen in silage. It can do that one and one other thing. But why wouldn't someone like John Deere hook that up to the marketplace, and then anybody in the world that creates a new model that just dumps it into the marketplace, now John Deere can just automatically inherit that use. Does that make sense? Yeah.
Okay, so if I can really easily maybe pay a small amount of money to classify a bunch of images, I don't have to manually classify the images myself, right? So most of the work's gone for me. And then I can just train a model based on that previous model's classification and re-upload it, and then I get the money instead of them, right? So how do you prevent that?
It's a great question, we don't. But if you think about it, if that guy was charging way more money, then you've undercut him. But the chances of you, reclassifying all his training images, they're not as easy to find as you might think. So if somebody had uploaded 40,000 training images and actually labeled them all, where did you find them?
I was thinking more like you gather.
Yeah, I mean, you could try. I gotta tell you right now, feel free to scrape the internet, but if some guy made a spectrometer algorithm for finding protein in wheat, the chance of you sending thousands of lab samples out to actually find the protein in wheat and then scan them all with spectroscopy, it's likely not available. But
And the idea in the marketplace, there will be multiple models that will compete, and and remember that whoever's model it is, they set the price. They might set it too high. Maybe they don't even understand their industry and what their industry is actually willing to pay, right? So then of course they might change the price, might go up, might go down, whatever. But it's a marketplace. We're not controlling that. I just want to because some of the things that we're looking for too is we really want to work with people like these guys with the drones and whatnot. What they really do is they have applications and they're selling their reports, right? They're selling their maps. But their maps are only really like this guy can do soybean there, right? But if somebody drops maybe a disease in soybean, and he can sell that map with it from his drone site. But if somebody here creates a model for corn, well, now all of a sudden, the corn one drops in there, he doesn't have to change any code, and now his application, he can create a map for corn disease, and wheat disease, and blight, and who knows, right? Does that, so this is kind of, I know we're talking about the business side of that a little bit more. But that's a big part of this is what, you know, we just want to try to communicate a little bit how are we thinking about, you know, this whole problem, and we try to step back and say, how do we democratize some of this? Because some of the challenges are in the real industry is there is not enough data science folks that can actually build and then implement these models for companies quickly and economically. So we have a place. Yeah.
So I think we can go on to batch effects, where a tool that works in one place doesn't work in another place because there's different machines, you know, different MRI machines, there are different sensors. I assume it's a serious issue for you guys also. So when someone wants to democratize this tool, he would say, this is assuming I got this type of soybean and using this sensor on this time of day in this season, or how does he specify when he thinks it's going to work?
Yeah. Okay.
Oh yeah, that's a great question, because that's absolutely true. And John kind of glazed over it, but there's actually a section in the site that says hardware.
Okay.
And in each of the hardware components, so we expect that if you make a model for a flame NIR from Ocean Optics,
Yeah.
that model will initially work with a flame NIR from Ocean Optics with the same settings.
Yes.
And we have some tooling to force those settings if you connect the device directly to our software. So in other words, if the author created it with this kind of averaging and this sort of exposure time, then it has to be reproduced on the end device as well when the predictions are being made. So that's absolutely true. I can see later though, if we did collect enough bulk amount of information, we could do some interpolation to create models that are more generic across multiple devices. But right now the sensor type absolutely matters.
Even more subtle things like this guy only took measurements between 10 in the morning until 4 in the afternoon.
Yeah, like you're talking about if you're outdoors now?
Yes.
Yes, absolutely. So an author in our case would have to put a description that said this model is only intended to work
Okay.
during this portion of the day.
And you prompt the author to make sure he specifies the machine type and the other specifications.
Yeah, and again, John didn't go over this section, but in terms of publishing to our marketplace, there's a review process
Okay.
where someone internal to Stream would look and say, was their description enough that someone could reproduce the results? Or was it like, hey, here's a model for carrots? And we'd be like, that's not nearly descriptive enough. No one could buy this and reliably use it. You know, try again. Great question.
Okay, just a quick thought on the business drivers. So right now we're a little bit focused. Yeah, you have a question? No. Okay, sorry. Right now we're a little bit focused on agriculture, and the reason is because there's a lot of crops, there's a lot of diseases, there's a lot of application here, and there's very little regulatory. It's the Wild West. We can get out there and you can look at detecting a disease in whatever, and no one's really going to say too much. When you get into health on the other side, and you want to say, yeah, this little thing here, that's cancer. Okay, now you know there's a whole regulatory issue. It might be, is a lot more rigorous. So that we've kind of just started with on the agriculture side, and the drivers, yeah.
Well, a cool thing on the agriculture side is that if you do catch a disease that's starting before it takes up the whole crop, you can actually save, the food supply of countries, right?
Well, I mean, yeah, and right now in these greenhouses, especially the cannabis ones where those crops are actually worth a lot, you can't afford to have your whole entire crop wiped out. I mean, it's just big dollars. So, they're really because money drives a lot of this stuff. So the other thing that's happening just on the business side of this is right now people take samples and they send them to the lab, right? Blood samples, soil samples get sent to a lab. Well, now if you could just take a picture or use a spectrometer and get the results, obviously. And some of it, not all the problems have to be so tough, like where the target is invisible, like protein, or it could be. You might be able to see it, but the problem is you've got a huge area to cover. right? So, like, how do you now get a camera you can put on a drone or on an airplane and cover a huge volume? And then of course there's the expert eyeballs, right? Right now in industries, in multiple industries, you hire experts to be able to look at things and then tell you, yeah, here's what we're seeing. And obviously machine learning is just perfect to replace expert eyeballs. So this is a little bit more on the business side. I don't know, maybe what we'll do just in the for time is just take some questions. And yeah, so let's go into Q&A.